Architectural design matrix. So we want to find out some numbers, some quantitative measure, so that we can understand what is the present state of architecture or the design. So architectural design matrix, they focuses on characteristics of the program architecture, emphasizing on architectural structures and effectiveness of modules or components. You know that the architecture is what? The overall structure of the software. And design is that total conversion of requirement so that it can be converted to the actual code. So now these things need some numbers, whether we have made a good architectural design or not. So these metrics which we are going to discuss, they are black box. We don't go into the detail, or we don't have any knowledge of the inner working. Cord and Glass, they define 3 software design complexity measures. What are these measures? These are pertaining to your architectural design. So the first one is structural complexity, then the data complexity, and the system complexity. Complexity, we have already talked about cyclomatic complexity. So this kind of complexity or this kind of measures or metrics can also be talked about in here. So here we have a call and return architecture. That is, the main module or main function will going to call certain function. Those functions are going to call again some functions. So these are a kind of call and return architecture. This is a hierarchical architecture. We have a proper hierarchy here. Okay. Now for this hierarchical structure, if we want to define these different complexities with respect to the architectural design matrix, the structural complexity of a module I, module can be a combination of functions. So this is defined as what? It's simply the square of fan out. For that module or that group of function or a separate function, just square the fan out. Now the question will be, what is the fan out? See, the fan out is the number of submodules this is going to invoke. For example, here there is a component. Now here we have different functions calling this component or this function. This is called fan in. That is, fan in is this function is invoked by others. But fan out is how many components or the modules or the function this component is going to invoke. Okay. So usually we want high fan in and low fan out. We don't want low fan in and high fan out. So fan out is that a module or a component, how many it is going to invoke. So this is the fan out. So just square it, you are going to get the structural complexity. Now coming to the data complexity. The data complexity is the complexity in the internal interface for a module I. How do we define it? What is the interface? How do you get inside a function or a module? Through variables. And what do you get from these functions or the modules? Variables. So we are talking about the number of input and output variables that are passed to and from this module. Vi divided by fan out plus 1. Fan out, we know number of modules or functions this module is going to invoke. But Vi or V is the number of input and output. For example, let me make a function. Assume that it takes 4 variables as input and it is returning, or say through pointer or by any other mean, it is returning say 2 variables. So number of Vi is the number of input and output variables. So in all we have 6. So that is what you are going to put it here. Fan out is number of modules this module is going to invoke. Coming to system complexity in the architectural design matrix, just add the structural complexity with the data complexity. This is the system complexity. because we already talked about the fan out and input output. So all these complexity, the question is, the word complex is complex. So the complexity value, if it increases, the overall architecture complexity will increase, and thereby the effort in integration and testing of these modules will increase.